Good morning, students. Good morning, math enthusiasts. Today, we will discuss about proofs of some geometrical statements involving SAA and HL theorems. These are additional triangle congruency theorems on top of ASA, SAS, and SSS postulates. To start with, let us discuss the theorems, SAA and HL theorems. Again, we shall be using the principles and some examples of Shalm's outline in geometry. The SAA theorem states that if two angles on a side opposite one of them of one triangle are congruent to the corresponding parts of another, the triangles are congruent. In the illustration, if angles A and B and an opposite side of angle B, which is line segment AC, of triangle ABC are congruent to its corresponding parts in triangle DEF, then the two triangles are congruent. The HL theorem states that if the hypotenuse and a leg of one triangle, particularly right triangle, are congruent to the corresponding parts of another right triangle, the triangles are congruent. In the illustration, triangles ABC and DEF are right triangles. Observe that the hypotenuse and one leg of triangle ABC are congruent to its corresponding parts in triangle DEF. Thus, we can say that triangles ABC and DEF are congruent. Again, remember that for the HL theorem to be used, see to it that the two triangles are right triangles. Example number 1. Given. Line segments BD and BC are perpendicular. Line segments BD and AD are perpendicular. And line segments AB and CD are congruent. Prove that triangle BAD is congruent to triangle DCB. This is the illustration. Now we will start understanding what we were given and proceed later to creating a plan of the proof. Line segments BD and BC are perpendicular. Line segments BD and AD are also perpendicular. Thus, angles CBD and ADB are right angles. Of course, this tells us that either angles CBD and ADB are congruent or triangles CBD and ADB are right triangles. We decide which consequence we are going to consider later. Line segments AB and CD are congruent. We need to prove that triangles BAD and DCB are congruent. To prove this, we simply need three corresponding parts of the two triangles congruent. Notice that we have corresponding parts already. Or notice that the corresponding hypotenuse of the right triangles are congruent. It is possible that we can use the hypotenuse leg theorem. Line segment BD is a common leg which is congruent to itself by reflexivity. Thus, by the hypotenuse leg theorem, these two triangles are congruent. Let us have now the formal two-column proof. Statement 1 is what we were given. Line segment BD is perpendicular to line segment BC. Statement 2 is the consequence of statement 1. Angle CBD is a right angle because perpendicular lines form right angles. Statement 3 is another given which states that line segment BD is perpendicular to line segment AD. Statement 4 is a consequence of statement 3. Angle ADB is a right angle because perpendicular lines form right angles. Statement 5 is a consequence of statements 2 and 4, which states that Triangles CBD and ADB are right triangles by the definition of a right triangle. Statement 6 is another given, which states that line segment AB is congruent to line segment CD. Statement 7 states that line segment BD is congruent to line segment BD by reflexivity or reflexive property. Finally, the conclusion is already arrived at. Triangle CBD is congruent to triangle ADB by the hypotenuse leg theorem using the statements 5, 6, and 7. QED. Example number 2. Given. Line segment AB is congruent to line segment BC. Line segment FD is perpendicular to line segment AB. Line segment FE is perpendicular to line segment BC, and F is the midpoint of line segment AC. Prove that triangle DAF is congruent to triangle ECF. This is the illustration. We were given that line segments AB and BC are congruent. The consequence of this given is that angles BAC and BCA are congruent. That one. We were also given that line segments FD and AB are perpendicular, and so do with line segments FE and BC. This implies that angles ADF and CEF are right angles. We focused on this side of the perpendicular lines because this is where we can locate two triangles. F is the midpoint of AC, which implies that line segments AF and FC are congruent. We need to prove that triangles DAF and triangle ECF are congruent. Observe that we already have three corresponding parts congruent, fortunately. Thus, we can say that triangles DAF and ECF are congruent by the SAA theorem. Here is now our formal proof. Statement 1 is the first given. Line segment AB is congruent to line segment BC. Statement 2 is the consequence of statement 1. Angle BAF is congruent to angle BCF by the isosceles triangle theorem. Statement 3 is another given. Line segment FD is perpendicular to line segment AB. Number 4, or statement number 4, is the consequence of statement number 3. Angle ADF is a right angle because perpendicular lines form right angles. Statement 5 is another given. Line segment FE is perpendicular to line segment BC. And statement 6 is, what do you think? Statement 6 is a consequence of statement 5. Angle CEF is a right angle because perpendicular lines form right angles. Statement 7 is the consequence of statements 4 and 6. Right? Okay, so angle ADF is congruent to angle CEF because all right angles are congruent. Statement 8 is another given. F is the midpoint of line segment AC. Statement 9 is the consequence of statement 8. Line segment AF is congruent to line segment FC by the definition of a midpoint. Finally, the conclusion is triangle DAF is congruent to triangle ECF by the SAA theorem considering statements 2, 7, and 9. QED. Example number 3. You are given quadrilateral ABCD, line segment DF perpendicular to line segment AC. Line segments BC and AC are also perpendicular. Line segments AE and FC are congruent. And line segments BC and AD are congruent. Prove that line segments BE and FD are congruent. This is the illustration. In quadrilateral ABCD, line segments DF and AC are perpendicular, and so do with line segments BE and AC. The consequence of this given is that angles BEA or BEA, BEC, CFD, or DFA are right angles. Notice that both sides of the perpendicular lines are considered because we are not sure yet which two triangles to focus in our flow of proof. We were also given that line segments AE and FC are congruent as marked. Also, we were given that line segments BC and AD are congruent. We need to prove that line segments BE and DF or FD are congruent. To do this, we may focus to the two triangles BEC and DFA. So notice that EF is congruent to itself by reflexivity. Thus, by addition property, we can say that AF, the line segment AF, is congruent to the line segment EC. Because we were already given that line segments AE and FC or CF are congruent. Notice also that triangles BEC and DEF or DFA are right triangles, and the given corresponding parts are hypotenuse, and we have now a leg or the two corresponding legs. Then we can say that triangles BEC and DFA are congruent by the hypotenuse leg theorem. Finally, by CPCTC, line segments BE and FD are congruent. In the formal proof, statement 1 is the first given. That is, line segment DF is perpendicular to line segment AC. Statement 2 is a consequence of statement 1. Angle AFD is a right angle because perpendicular lines form right angles. Statement 3 is another given. Line segment BE is perpendicular to line segment AC. Statement 4 is again a consequence of statement 3. Angle CEB is a right angle because perpendicular lines form right angles. Statements 5 and 6 were also given. So line segment AE is congruent to line segment FC, and line segment BC is congruent to line segment AD. Statement number 7 states that line segment EF is congruent to line segment EF by reflexive property or reflexivity. Statement 8 states that line segment AF is congruent to line segment EC by addition property. Statement 9 is a consequence of statements 2 and 4. Triangle AEB and triangle CEB are right triangles, by definition of a right triangle. Statement 10 states that triangle AFB is congruent to triangle CEB by the HL theorem. And finally, line segment BE is congruent to line segment FD by CPCTC or particularly or specifically CSCTC. QED. Example number 4 wants us to prove that in an isosceles triangle, altitudes to the congruent sides are congruent. The hypothesis of The sentence is, in an isosceles triangle. And the conclusion, altitudes to the congruent sides are congruent. From the hypothesis, we need to draw an isosceles triangle, A, B, C. From the conclusion, altitudes to the congruent sides are to be drawn. So in the illustration, line segments CE and AD are the altitudes. We need to prove that these altitudes, or line segments CE and AD, are congruent. This is the restatement of example number 4 that is derived from the illustration. So given isosceles triangle ABC, an AD, line segment AD is altitude to line segment BC. Line segment CE is altitude to line segment AB. Prove that line segment AD is congruent to line segment CE. We were given that triangle ABC is an isosceles triangle. As a consequence, we can say that line segments AB and BC are congruent. As a consequence of the previous consequence, angles BAC and BCA are congruent. We were given that line segments AD and BC, this AD and CE are altitudes. This implies that angles AEC or AEC and CDA are right angles. So we focus on this side because we can see that these were given. So we try to focus on these two triangles here. Now, to prove that line segments AD and CE are congruent by CP/CTC, we first need to prove that these two triangles that contain these segments or line segments are congruent. So again, we consider triangles AEC and CDA. Notice that there are two corresponding parts congruent. These are overlapping triangles, so you can see these parts and these parts. So line segment AC is a common side, as you can see. So we can say that line segment AC is congruent to itself by reflexive property. How many parts do we have now? There are 3 parts, so we can prove that triangle AEC is congruent to triangle CDA. And by CP/CTC, we can prove that line segment AD is congruent to line segment CE. Let us now proceed with a formal proof. Statement 1 is what we were given, isosceles triangle ABC. And statement 2 is the consequence of statement 1. Line segment AB is congruent to line segment BC because of the definition of an isosceles triangle. Statement number 3 is a consequence of statement number 4. Angle BAC is congruent to angle BCA by the isosceles triangle theorem. Statement number 4 is another given. Line segment AD is altitude to line segment BC. Statement 5 is a consequence of statement 4. Angle CDA is a right angle because perpendicular lines form right angles. Statement 6 is another given. Line segment CE is altitude to line segment AB. Statement 7 is the consequence of statement 6. Angle AEC is a right angle because perpendicular lines form right angles. Statement 8 is a consequence of statements 5 and 7. Angle CDA is congruent to angle AEC because all right angles are congruent. Statement 9 states that line segment AC is congruent to line segment AC by reflexive property. Statement 10, triangle CDA is congruent to triangle AEC by SAA theorem, or considering statements 3, 8, and 9. Finally, Line segment AD is congruent to line segment CE by CP-CTC or specifically CSCTC. QED. In our recap, two more principles for proving triangle congruence were discussed today. The SAA and HL theorems. This is an addition to the three postulates discussed in our previous videos, SAS, ASA, and SSS postulates. There are now 5 principles to consider in proving triangle congruence. That ends our discussion for today. Thank you very much. Remember, math is easy to learn when one learns with enthusiasm. Bye!